Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we'll go through angles of elevation and depression. So this is something you would have gone through in year 9 or 10. So let's go through this by using an example. So let's say the angle of elevation to the top of a building at a point 7 meters from its base is 83 degrees. How tall is the building? So whenever you're given a worded question like this in trigonometry, but not given a diagram, first draw a diagram. So what we have here is we have some building. I'll just represent with a line because we only want to find its height. So I'll call that height x. That's what we're trying to find. Now, the point of angles of elevation and depression, what they allow us to do is take 3D problems. So, a building is three-dimensional. But what we're going to do is represent this problem in 2 dimensions. And we're going to represent it with a right-angled triangle. So then we can just use our normal SOHCAHTOA to find either an unknown side or an unknown angle. In this case, we're finding an unknown side. So what we're going to do is turn this into a right-angled triangle. So we're told information when I'm 7 meters from the base of the building. So the base of the building there. Now this will be a right angle. It's safe to assume that a building is at right angles to the ground. So to make it a triangle, I'm just going to draw a third side here. So we don't have enough information yet to find x. What we need is also an angle, and that's where this angle of elevation and depression comes in. So I'm just going to draw another horizontal line here. Now this angle here is called the angle of elevation. So elevation means up. The angle of elevation is the angle made with the horizontal line when you're looking up at something. So this would be the angle if I was standing here, the angle made when I'm looking up at the top of the building. The angle of depression is this angle here. So depression means down. This is the angle made with the horizontal when I'm looking down at something. So this would be the angle made if I'm on top of the building and looking down at this point. So I actually use theta to represent both of these angles. That's because even though they're different concepts, elevation and depression, the two angles are always equal. So I was told in the question that this angle here, angle of elevation, was 83 degrees. So that means that this angle here is also 83 degrees. They're always equal because they are alternate to each other. So you need to remember that both the angle of elevation and angle of depression are angles made with the horizontal line. This is the angle made with the horizontal line. This angle here is with the horizontal line. This angle here, however, is the angle with the vertical line. So the biggest mistake people make in questions like this is they put the angle of elevation or angle of depression in the wrong spot. Remember, angle of elevation, angle of depression are angles made with the horizontal line. If you understand all this, this question is easy. We have a right-angled triangle. We have an angle other than the right angle, a side, and want to find another side. We're just going to solve this using normal SOHCAHTOA. So x, the side we're trying to find, is opposite the angle that we're given. This 7 meter side is adjacent to the side we're given. So hopefully you remember from SOHCAHTOA, if you have opposite and adjacent, use tan. So step 1, choose the correct ratio. Step 2, turn this into an equation. So we have tan of angle equals opposite over adjacent. So hopefully you remember from the last video, if the thing you want to find is on top, you multiply. So the answer here will be x equals 7 times tan 83. So of course this angle given was in degrees. Your calculator needs to be in degrees. You should get approximately 57 meters, and that is the height of the building. All right, thank you so much for tuning in. This has been the luckiest maths teacher in the world. Have a great day.